Welcome back for another calculus lesson with Mr. Thompson. This time we're in section 4-4, looking at the derivatives of all of the other trigonometric functions. So it's just a nice list that we're going to come up with, and then I'm going to show you where they come from because you might think that some of them seem pretty out there. So first of all, the simple ones. Sine of x becomes cosine of x, and cosine of x becomes negative sine of x. All of the other trig functions come from this. Now, we end up using product rule, quotient rule, and that kind of stuff. That's why we haven't looked at them yet. But now that we know those, it's not pretty hard to come across. So let me go ahead and write down the list that you see on page 142. So these are the basics. Now we also have the tangent becomes secant squared x, and that's one where you might, wonder what's up with that. We have cotangent of x becomes negative cosecant squared x. Once again, seems kind of out there. Secant x becomes secant x tan x. And finally, the cosecant x becomes cosecant, or negative, sorry, cosecant x cotangent x. So, might seem kind of out there, but you can probably see some coincidence. Anything that starts with cosine, cotangent, cosecant, the derivative is always negative. Okay. Both tangent and cotangent wind up with something squared. Both secant and cosecant wind up with a product. Now, let's see where they come from. So, we can build all of these bottom ones using only the two on the top. Otherwise, there'd be no proof in this. You can't prove things involving each other. You have to prove it all from something that's already been proven, and we already looked at the proofs of cosine and sine. So, let's do a simple one. Example, if y equals tan of x, find y prime. So, I could just look at my list and say, hey, it's secant squared x, but I'm not going to. What I'm going to do is I'm going to rewrite this. Tangent is sine over cosine, and now it's a quotient rule. Top is sine of x, bottom is cosine of x, u prime is cosine of x, v prime is negative sine of x. Now, on the top, u prime v, cosine squared x, minus uv prime, so minus minus is going to be positive, sine squared x, all over v squared, so cosine squared x. Now, there is a step here, a simplification. Something you got to remember is a trig identity. Cosine squared x plus sine squared x equals 1. So 1 over cosine squared x, which is secant squared x. Okay, that's where it comes from. Now, just memorizing it is probably easier. You don't want to do that every single time, especially the trig identity, but it's not a hard one to know where it comes from. Let's take a look at another example. How about secant x? Because cotangent x would be pretty much the same thing, just everything flipped. Be cosine over sine, v and u would be swapped, and so stuff down here would be swapped, but for the most part it's the same thing. Now, example, if y equals secant x, find y prime. Now, first of all, rewrite it as a quotient, 1 over, secant, so that's cosine x top is 1, bottom is cosine x, u prime is 0, v prime is negative sine x. So y prime, the top, u prime v is nothing, minus negative, so positive, uv prime. So that's just sine of x over v squared cosine squared. Now, we're saying this equals secant x tangent x. And so our slow bit simplification to get into this. So this equals 1 over cosine x times sine over cosine, which is tangent, which equals secant x times tangent x. And that's it. Now, need to remember some other things as well. Some I can go over all. They're pretty much just as simple as that. So let's look at a problem from the book, from the problem set. How about number 17? So this applies a natural log as well as something inside the trig function. So let's see how this works out. So 17, y equals 5 natural log of 7x over cotangent 14x. Now, this technically is a quotient rule as it is. So I'm going to go ahead and split that. U equals the top, 5 natural log 7x. V equals the bottom, cotangent 14x. Now I'm going to rewrite it as a quotient itself. So cotangent 14x is cosine 14x over sine 14x. Now I'm doing that because I want you to see what happens to the 14. So natural log, or the derivative of the top is easy. U prime, let's see, derivative of the inside, let's see, is 1. So 1 goes on top of the 5, so we have 5 over what's on the inside, 7x. That's u prime. V prime, I'm going to have to do quotient rule. So this is a quotient rule inside quotient rule. So down here I'm going to do u is cosine 14x. V is sine 14x. U prime is negative 14 sine x. Sine 14x. V prime is 14 cosine x. Now, according to the quotient rule, u prime v, so negative 14 sine squared 14x minus, let's see, uv prime, so 14 should be there as well, my bad, minus 14 cosine squared x all over v squared, so sine squared 14x. Now, the top, I can factor out the 14, use the trig identity again, so that ends up equaling 1, so it winds up being negative 14 on the top over sine squared 14x, which equals negative 14 secant 14x. Okay, secant 14x. Now, notice it was just derivative of the inside. Let me go back up and make sure. Oh, I missed my squared. That's what I was messing up. So missed my squared, there it is. So, it wound up being derivative of the inside on the outside is all, just like we've kind of come to know. So, v prime is negative 14 secant squared 14x. Now I can do my quotient rule of this. So I'm going to find some room down here. So u prime v, 5 over 7x cotangent 14x. So 5 over 7x cotangent 14x minus uv prime. Minus minus can be positive. 5 times 14 is 70. So plus 70 natural log 7x secant squared 14x. All over v squared. So all over cotangent squared 14x. Alright, so that's it. Winds up being quite a bit if you have to use 2 quotient rules in a row, but it still does work out nicely. Okay, so now you have the derivative of all the individual trig functions in your bag of tricks, so you can use them to find a lot more derivatives.